Do you know the unique security risks of cloud computing? Have you implemented best practices to lock down your cloud data, apps, and infrastructure? Welcome back to ARCROTGIS Technology College. In today's video, we're diving deep into the world of cloud security. Discover the major threats, uncover trusted solutions, and learn the key strategies to safeguard your cloud. Let's get started. Cloud computing provides access to computing resources like storage, servers, databases, networking, and software applications over the internet. Rather than owning the physical infrastructure, users access technology services through the cloud vendor. This gives flexibility to scale services up or down on demand. Infrastructure as a service, or IaaS, provides building blocks for cloud like virtual machines, storage, networks, and operating systems over the internet. Users still manage applications and data. Platform as a service, or PaaS, provides tools and environments for users to develop, manage, and deploy applications without maintaining infrastructure. Software as a service, or SaaS, provides access to complete applications running in the cloud through a web browser. Users don't manage hardware, operating systems, or storage. There are also different cloud deployment models like public, private, and hybrid clouds. Public clouds are owned and operated by third-party cloud service providers like AWS, Azure, or Google Cloud. Private clouds are dedicated infrastructure operated solely for one organization, managed internally or by a third party. Hybrid clouds combine both public and private cloud infrastructure. Migrating to the cloud can benefit your business in many ways. You don't need to buy hardware, just pay for what you use. You can quickly add or remove services to meet your needs. Employees can access apps from anywhere to work mobile. You get faster computing with top infrastructure. Cloud companies promise reliable services. You can collaborate in real time from any place. The cloud offers advanced security options and skills. Overall, the cloud provides cost savings, flexible scaling, increased productivity, better performance, enhanced reliability, easier collaboration, and improved security. While cloud computing offers advantages, it also poses unique security risks. Some key challenges include data breaches due to increased attack surfaces and distributed data leading to higher breach risks from hackers, insiders, or human error. Account hijacking can occur through phishing, weak passwords, and insufficient access controls, resulting in compromised accounts. Insecure interfaces like APIs, consoles, and management interfaces can have vulnerabilities open to exploitation. The multi-tenant nature of cloud means organizations share infrastructure with unknown third parties. Public cloud users also have limited visibility into the underlying infrastructure. Cloud models can conflict with regulatory compliance needs for data sovereignty, residency, and security. There may also be insufficient expertise with lack of trained staff to properly configure and monitor cloud security controls. The ubiquity of cloud makes it an attractive target for advanced threats like sophisticated malware and ransomware. Cloud's centralized infrastructure is also vulnerable to distributed denial of service attacks. Finally, complex security settings often lead to misconfigured services, apps, storage, and networks. A robust cloud security strategy consists of people, processes, and technology to protect data, apps, and infrastructure. Core elements include establishing accountability for cloud security decisions and updating security policies for cloud environments. Organizations should align controls with industry standards and regulations and conduct risk assessments weighing benefits versus security trade-offs. For identity and access management, centralizing identity management and access controls is key. Multi-factor authentication should be enforced across all access points, along with single sign-on for integrated applications. The identity lifecycle, including provisioning, deprovisioning, should be automated, and access permissions configured based on least privilege. For data security, organizations should classify data types and implement data loss prevention controls. Data should be encrypted end-to-end with customer-managed encryption keys, and its access, transfers, and changes monitored through data loss prevention. Backing up data regularly and testing restoration is also important. Application security requires embedding security into design, development, and testing. Both static and dynamic analysis should be performed to identify vulnerabilities, and security controls validated before deployment to cloud environments. Applications and APIs should be protected with web application firewalls. To protect infrastructure, virtual machines need to be hardened against cyber attacks. Components should be segmented into trust zones based on risk, with intrusion detection prevention systems implemented. Traffic should be filtered using next-gen firewalls to restrict lateral movement, and infrastructure logs monitored for anomalies and threats. By taking an end-to-end approach across these pillars, organizations can establish a defense-in-depth security posture adapted for cloud environments. There are some key solutions and best practices for securing critical areas of cloud computing that warrant further discussion. To protect cloud accounts and access, strong passwords, multi-factor authentication, and single sign-on should be enforced. Access permissions need to be configured based on roles and responsibilities. Provisioning and deprovisioning of user accounts must be automated. Unauthorized access attempts can be detected using user behavior analytics. Account access should be restricted to authorized networks and geolocations. For securing cloud data classification, retention, and protection policies are important. Data in transit and at rest should be encrypted using customer-managed encryption keys. Sensitive data fields like credit cards and social security numbers should be tokenized. User access to specific data objects can be controlled through access control lists. Monitoring data use across cloud services requires data loss prevention tools. Safeguarding cloud applications necessitates embedding security across the software development lifecycle. Code repositories should be scanned to identify vulnerabilities before deployment. Open source components should be validated to contain no known vulnerabilities. Cloud resources like storage buckets, message queues, and databases need to be hardened. Applications and APIs require protection, using web application firewalls and API gateways. To monitor cloud infrastructure, performance logs, user activity, and network traffic need continuous monitoring. Cloud access security brokers can detect threats and anomalies. Penetration testing should mimic real-world attacks. Next-gen endpoint detection and response tools should be implemented on cloud servers. Outbound internet connections should be restricted to minimize malware impact. For securing cloud networks, cloud environments require segmentation into private networks based on risk profiles. Communication between network segments needs to be restricted using virtual firewalls. Web application firewall rules should filter inbound and outbound traffic. A zero-trust architecture with software-defined perimeters provides security advantages. Network traffic should be encrypted end-to-end across virtual private networks. To mitigate DDoS risks, cloud resources need to scale instantly to absorb large traffic spikes. DDoS traffic should be filtered close to the source before reaching cloud data centers. Attack traffic from known malicious IP addresses can be blackholed. Maintaining web application security defends against Layer 7 DDoS. DDoS mitigation services should be available to divert attack traffic on demand. For compliance, cloud security controls need to be mapped to regulations like HIPAA, PCI, DSS, GDPR, and CCPA. Some innovative technologies are also evolving to provide enhanced cloud protection. Cloud access security brokers, or CASBs, offer visibility, monitoring, and control for SaaS applications. Capabilities include data loss prevention, behavioral analytics, malware detection, and encryption. Microsegmentation and software-defined perimeters create secure zones in data centers and cloud deployments to isolate workloads and restrict lateral movement. Granular access controls are enforced at the application level based on role and context. Cloud workload protection platforms protect virtual machines, containers, serverless functions, and data services using next-gen antivirus, firewalls, and intrusion detection capabilities tailored to cloud environments. Cloud security posture management tools provide insight into misconfigurations, policy violations, vulnerabilities, and threats across public cloud environments using automated scanning. Security teams get alerted to issues impacting cloud-based resources. By deploying advanced solutions like these, organizations can develop a robust, risk-based cloud security program aligned to business needs. How will you apply these cloud security best practices to reduce your organization's risks? What innovative solutions appeal most to advancing your cloud protections? Let us know in the comments section. And if you like this video, be sure to like and subscribe to ARCROTGIS Technology College for latest practical cybersecurity tips, which will help you to protect your assets in the cloud and on premises. Thanks for watching.